We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRAE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRAE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRAE helps formalize industry codes and standards. ISHRAE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRAE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRAE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRAE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, AHU India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The AHU exhibition is now growing from HVAC and R Show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AHREConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRAE to catalyze the transformation of the budding engineering professionals. ISHRAE provides a platform to potential employers to select student members for careers in HVAC and R industry at the ISHRAE Job Junction. Young minds are made aware of the need for saving power, clean air, and sustainability. The K-12 initiative of ISHRAE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRAE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, and energy efficiency and conservation, to enter and explore the universe of the Indian HVACR industry. Log on to ISHRAE.in that unfolds a panorama of information Let us engineer a sustainable future together through ISHRAE.
Our world is changing. Cities are growing, food is moving faster, further, and we want healthier, more comfortable lives. These changes are driving up the demand for energy. So who's enabling more energy-efficient homes, cities, and industries? Armacell. We understand the world's energy demands and engineer solutions that make a difference. Solutions that help save energy, lower costs, and reduce emissions. As a global leader in equipment insulation, we are tackling the energy challenge, since the smallest things have the biggest impact. We manufacture equipment insulation, engineered foams and aerogel blankets, helping homes to optimize energy efficiency in solar applications, skyscrapers to reduce energy losses in air conditioning and water piping, trains to provide fire-safe insulation, onshore pipelines to prevent corrosion under insulation, and wind turbines to make renewable energy production possible. We invest in new technologies, focus on superior product performance, and constantly innovate thinner, lighter and more environmentally friendly products, so we can help cities meet the needs of energy distribution and enhance living comfort through thermal and acoustic insulation. Our vision is shared by 3,000 employees around the world who make Armacell a trusted and reliable partner and support our customers in more than 100 countries, where every individual has a passion to make a difference in our mission to enable a more energy-efficient world. Discover how at armacell.com.
A technology leader offering total fluid dynamics and handling solutions. KSB attributes the highest importance to optimal quality and customer care, because for us, the customer is our world. KSB is that name that has been taming fluids for about a century and a half, with their long perfected solutions for every industry and for customers that need them. Established in 1871 in Germany, today the group has over 90 companies, employing over 16,000 employees and with a turnover of over 2.3 billion euros, and is one of the leaders in this field worldwide. Heir to this lofty tradition of technological leadership, KSB came into existence in India in 1960 with its first factory in Pimpri in Pune. Today, KSB in India manufactures and offers an illustrious star cast of pumps, valves, and a tight array of services from 5 ultra-modern factories across India, fulfilling the needs of a diverse and knowledgeable domestic and international customer base. And now, to cater to the growing demands of the energy sector, KSB is poised to set up yet another state-of-the-art manufacturing facility in Shirwal near Pune. So whether it is submersible pumps or pumps for nuclear reactors, several innovative solutions have made their debut on the shop floors of KSB in India, with the objective of offering best-suited solutions to our customers' needs and with the intention to be ahead of time all the time. When customers describe their needs, we listen intently. Sometimes it may mean a standard pump or a valve, and sometimes a whole tailor-made solution. We have set for ourselves high standards, often as high as the highest building for transporting water, fresh water, hot water. and even water for firefighting, to a host of offices, airports, and industrial complexes. In the power sector, we help to produce more power with less fuel and ensure cost effectiveness in the most critical conditions. And that's why our excellence is energy in constant motion. In the petrochemical and refinery sector, our pumps and valves perform with choreographed finesse in handling hazardous and cryogenic liquids. Our products handle extreme pressures and temperatures effortlessly, whether it is for handling water or aggressive and corrosive fluids, or viscous and solid-laden fluids in industrial processes. KSB pumps have been relentlessly working in the agriculture and irrigation sectors for decades, reliably supplying water to farms and fields across the length and breadth of the country. Even when it comes to pumping with non-conventional energy sources in rural India, we romance the life-giving element, water, with great panache. When it comes to handling wastewater and effluents, our products perform responsibly and with grace. Your wish to expect the best from us inspires us to keep innovating and offer the best to you. KSB, our technology, your success, and that's a promise.
Good afternoon, and thank you everybody for joining this workshop. And definitely, we are very much thankful for Murlikant sir for this session. Before going to the exact session that we are going to deliver by Murlikant sir, the topic is design and installation of AHU and UV. Few slides are pending with us for our annual partner. I'm going to run this. Hardly it will take 10-12 seconds. Then we will start the. So ALP Aeroflex is basically into the innovation solutions for greener world. They are the insulation solution provider. You can say few details about the LP Aeroflex. They have portfolio over 10,000 products. They are into the global construction industries and automotive sectors as well. Founded in 1985, 11 companies spread across the globe. Turnover USD 160 million across. Few things about the LBR Flex. Key certification you can see over there. Key projects they have done in airport, hospitals, IT sector, industries, different kind of industries, government, educational institutes, and prestigious international projects. Also, they have done apart from the India as well. So, few baseline of product you can see Aeroflex, Aerocell, and Flex Eco. And further any queries you can directly contact to LP Aeroflex in the given number, or you can drop down the mail at marketing@lpaeroflex.com, or you can go to the website and numbers are also displaying over there. So any mod you like, you can go through this regarding any kind of installation solution. So thank you very much. And once again, we are thankful for all the annual partners, platinum partner Almacel, and gold partner LP Aeroflex KSB, silver partner Briar, DRI, Syscam, Advanced Wall, Mervex, and annual partner Andrews Hydro, Paramount Polytreat, Keflex, and membership partner in Standard Recreation. So yes, today E.R. Murlikant is there with us, so we are very much thankful to them. Before going to the PPT of them, a few lines I would like to read for Murlikant sir. He is also a veteran for this industry. I think you must know, but few protocols we have, so we will follow this. So, Mr. Murlikant is the mechanical engineer with more than 35 years of experience, presently working as a freelance consultant, providing consulting services in HVAC, fire protection system, storage tank, utility, and chemical process piping system. He is associated with the some of leading architects and MEP consultant in Chennai, mainly for clean rooms and hospitals. His core areas in HVAC are clean room design, low RH system requiring lower than 15% RH process, flue gas treatment for chemical factories, dust control system for powder handling processes, and HVAC integrations with the fire protection system. He has been working with different industry in past 35 years, mainly with the chemical factories and pharma industries, where indoor as well as exhaust air quality both are important. He has given some training programs in the past few years at ISHRAE Chennai chapter, uh, and also directly to some reputed HVAC industry and Chennai. All topics on clean room and RH for industrial applications. Apart from this, of course, Mulikan sir has delivered many topics in the platform of DCI, Delhi chapter of ISHRAE as well. So he has done three webinars already. I mean, for Delhi chapter of ISHRAE on different topics recently. So welcome, sir. Welcome to this forum again. And I think it's your time now. And over to you. And time being, we follow the same agenda that we have followed previously in your webinar.
Yeah.
Like anybody have any question, they can send us to in Q&A section, and we will take after the completion of this workshop. So over to you, sir. Thank you.
Yeah, good afternoon, all of you. Hello, am I audible?
Yes, sir, you are audible.
Yeah. Good afternoon, all of you. I am very much thankful to ISHRAE Delhi for giving this opportunity once again. In fact, this is my fourth session in the past 6 months. This chapter being organized jointly by Delhi ISHRAE, Chennai ISHRAE, and AHRAE Chennai. All these, I really thankful to them for giving this opportunity to share some of my learnings in this program. Before we get into the main topic, I would like to tell a few points in this session. That is, we are not talking about intricate design of AHUs. We are only talking an outline where each component requirement is understood and how to place them, what to place them, and how to move with them for effective air conditioning. So let me go to the slides now.
Please go through the shares here.
Yeah, visible now? Visible?
Yes, sir, visible.
Okay.
Please go to the slide some more.
Yeah, I guess so. Yeah. Topics covered: AHU, a brief description; ventilation units, a brief description; difference between AHU and VU; components and its role; type of AHU and comparison; summary and conclusion. In this chapter, above topics 4 and 5 are very, very important because they have a definite importance. Each component in the AHU or ventilation has a role to play, and how effectively we have to choose them. I will outline to you so that people can understand very well. Calculations for heat load, coil sizing are not covered in the session. Single skin, double skin profile, and other features are not covered in the session because heat load or coil sizing is a different topic altogether. It needs a separate detail working on that. So we are not going into those things now. AHU means air handling units to circulate air into the conditioned space, to give filtered air into the conditioned space, to maintain temperature and humidity in the conditioned space, to maintain the design state of thermal equilibrium at all times, and to maintain adequate oxygen level in the conditioned space based on the design features. The thermal equilibrium is very important. If somebody has among the audience last time attended the ducting program, you would know how important it is to have a thermal equilibrium while planning the ducting. So those things we'll not discuss now, but I just want to emphasize on the thermal equilibrium also. Okay. Then ventilation unit shall bounce through airflow system into a designated space to provide ventilation across the designated space, provide filtered air in designated space, to expel hot air, stale air from the space. Air within the space is not recycled. So in AHU it is recycled, whereas in ventilation it is not recycled. This is the simple mechanism. And ventilation unit has a combination of supply units and exhaust units suitably to meet the airflow demand within the designated space. So the importance of these two things, I'll go into further deeper. Main thing is when you're putting the AHU in open to atmosphere and in a closed room, installation plays a very important role. That when we go into the further papers, we'll come to know how the performance is varying while keeping the equipment indoors or outdoors. Now, difference is simple table, parameter, filtration in both the cases, yes. Recycling in AHU, yes. In ventilation, is no. Fresh air content partial in 100%. Temperature, yes. No. RH control, yes. To up to some extent. In ventilation, is no. Clean room application, yes. In ventilation, is no. Now, temperature control in air washer can be achieved with some water spraying, but RH control cannot be got at all. Okay, and whenever you want to RS below 50%, and dehumidifier is required. Okay. Now, ventilation diagram unit, fresh air, this is 20 micron, fan motor, 10 micron, supply air. Now, these are the main two differences we'll be talking in the coming papers now. We have got two types of AHUs. One is blow through and one is draw through. The upper one is blow through, where we have fresh air, 20 micron filter, 10 micron mixing return air chamber. Then we have this fan motor assembly unit here, then cooling coil, mist simulator, then a heater, then 5 micron and supply air. It is a draw through, but normally you everybody see in the all the scenarios. Fresh air, return air is here, cooling coil is here, fan motor, a 10 micron, then heater, then 5 micron, and this is draw through. In the both this case, if you carefully observe, this cooling coil in blow through is put after the fan, and here it is put before the fan. So this is a very important features which many people are not fully aware of. Okay, we'll talk this in detail. We go further. Okay. Now components and its role. 20 micron filter is coarse filtration. Particles up to 20 micron will filter and balance will escape. Then 10 micron coarse filtration. Particles less than 20 and more than 10 are filtered there. And 5 micron filters fine filtration, that is particles less than 10 and up to 5 will filter. Fan plus motor is for airflow, cooling coil for temperature control, and also importantly, it does wet filtration. How we do wet filtration? I'll just again go through here. Whatever the fresh air having some foreign particles will get filtered here. Okay, and something will get filtered here, and it comes here. Now there is a complete water particles sitting on this coil. So what will happen is the flying dust will capture here and will make this 5 micron filter longer life. Here also it is the same thing, but there is a difference here. The water carry forward will be very high here. This I will explain to you in the coming process. So cooling coil not only does the work of cooling energy, it also does the work of wet filtration. So with this we are having a longer life or 5 micron or whatever the filter down the line you have. Okay, this we'll explain a little later when coming papers. And mist eliminator again to prevent carry forward of water droplets. Go back here again. This here in this figure you don't see mist eliminator in the bottom one, which meaning people do not put. Here we have mist eliminator. See the fan is having a draft. So what will happen is flying water particles will try to move along with the air. So after the cooling coil, this flying water drops will hit the mist eliminator and fall down. So we have a better collection of condensate. So this condensate will prevent the moisture after accumulating here, will reduce the moisture carry forward into the controlled space. So this is the one of the important thing. Whereas in this case, there is no misalignment, which many people don't put. What will happen is flying water moisture will still be carried forward down the line into the room. So this is a small drawback here. These filters will not, to some extent, yes, will remove the moisture, but not completely. Here is a better effect. Again, I'll come to this blow through of the mechanism in the coming papers. Heater, as we know, hot water or electric heater, something is there depending on the available energy source for heat of the air, and dampers to adjust the airflow and air balancing. So these are the various components of any air handling units. In ventilation unit, yes, we have mist eliminate, we have a water spray system which gives the cooling for the fresh air and reduce temperature to some extent. Now coming to this ambient air dust quality. This data up to 2014 is available, and further data is still not released by the Indian IMD and other agencies. Okay, this is at various cities across India. Okay, now atmospheric particle concentration PM10, that is 10 micron. If you see here, in 2004 till 2014, and more or less this pattern is same only, not much change as per the website. Officially, they not published any paper, but it's almost same. Concentration of 100 micron particle is almost 10 micrograms per meter cube. This is the concentration of 10 micron particles. So when we put the air handling unit open to atmosphere or within a closed room, the effect will, I will share you how it behaves. From the figure evident, the 10 micron particle, the average particle concentration is in the range of 100 to 50 micrograms per cubic meter. The data for more than 10 microns are not published recently, hence not captured. The particle concentration varies across climate, weather conditions, nearby construction work, vehicle traffic, factories, etc., as per the place of living, working. According to WHO and other standards, indoor quality, long-term exposure PM 2.5 is accounted and monitored in certain places. So particles, if you are maintaining particle 2.5, a dozen, and if within limits, naturally above 2.5 is with a very less, I would say. Okay. Particles bigger than 2.5 not considered to remain indoor quality. Reason: if the indoor quality is within limits of 2.5 micron, it automatically defines a particle bigger than 2.5 micron are negligible since the filtration is proper and well maintained. Now, for effective indoor dust quality, proper selection of filters very important. Generally, 20 micron, 10 micron filters are considered in most comfort applications and ventilation applications. 5 micron filters are considered in little advanced comfort applications and industry specific. 3 micron HEPA filters are applicable for clean applications like operation theaters, hospitals, electronic industries, pharma industries, etc. Now, most of the industries in India are driven by comfort application only, but 20 micron and 10 micron are vastly used. Of course, after this COVID incident, many people are considering 5 micron. Even to some people are asking 3 micron filters also. But if the filters are not maintained properly, what will happen? We will not have any proper good quality of air. And similarly, if you are putting the AHU open to atmosphere or in a closed room, the effect of atmospheric particle load is very, very great. Let us go through some of the other features. Now, if you are putting the outdoor, the ventilation units and the AHUs, what are the various implications? Flying construction dust within the vicinity of premises. Okay, so for neighboring buildings and construction is going on, or within your factory, your expansion is going on. What will happen? The dust will come to the AHU based on wind direction. These dust particles like mud, cement, brick, and all will be going and choking the 20 micron filter very soon. What will happen is there will be airflow starvation. When the filter is choked, there will be not much full fresh air coming into the system. This will lead to fresh air reduction in the system. So what will happen? This will get high vacuum in the fan, and after some days, the filter will get damaged because of constant exposure to high vacuum. Now again, flying insects, leaves, paper, cloth, etc. will come and sit on the filter. So it will again choke the filter. Again, same consequences. Now rainwater directly pulled by the fan due to vacuum force. Now rainwater plus dust will form a thick sludge on the filter mud paste and not allow the air to pass through easily. So just imagine when you are keeping the AHU or ventilation unit open to atmosphere, how much dirt is being pulled daily by the system. So what will be the life of the filters? Let us go through the average life of filters. Now, as before, as informed previously, we have 20 micron, 10 micron filters, followed by 5 micron, 3 micron, HEPA, etc. Now, what happens when filter is chokes? It's evident that 20 micron filter will choke first since particles bigger than 20 micron are trapped. There's always a vacuum pull by the fan suction. This constant vacuum pull in due course of time shall damage the filter edges, fabric along the filter outer body frame. It's very common. When you're constantly putting vacuum force, what will happen? It will gradually damage the filter and open will become bigger. Remember, the filtering media fabric is glued to the metal frame. There's some paste they'll apply, some adhesive, and fabric filtering media is sticked onto the frame. So it's not a welded type like that. This glue has limited bonding. In high vacuum for long period, the glue gradually peels off and that is the fabric media gets opened up. So what will happen when the filters are damaged? You have unfiltered air easily entering into the AHU body. So when 20 micron fails, automatically the 10 micron is loaded 10 microns more particle. So when you see the consequences, 10 micron, 20 micron filters partly damaged. So what happens? The particles bigger than 20 micron will pass through the holes and load the 10 micron filter. And 10 micron will get choked very fast. This is again going to next filter. So because of high vacuum, 20 micron is damaged. So on 20 microns, bigger size will pass through, will go and choke the 10 micron. Again, it is getting choked. It is again getting vacuumed, peeled off, damaged. Again, carry forward. And like that, what happens is totally gradually all the filters will start leaking. So what will happen? All your environment dust control goes high. Okay. If it is filter is fixed after the fan, here also whatever the particle that has come 20 micron filter shall gap or hit the next filter. Now there is small difference in the vacuum is different and positive friction is different. In vacuum, the pull is very high, it will majorly peel off the filter media from the frame. Whereas in positive side of pressure, the particles go and hit the filter like a bullet and make small holes. So they will get punctured in due course of time. So this is very important. So the fan is having the capacity to throw the particles very close to the filter, and filter gets punctured very fast. So that is why filter life is very important. Here are some of the this one figures. 20 micron damage by high vacuum along the just because of bonding between media and glue. Here you see redder dots are there along the periphery because of constant vacuum. This is getting damaged. When it's kept in fan, suction exactly happens. Okay. When filters came to the compressed air pressure, then all this happens. People should be very cautious when using compressed air to clean the filters. If you use the compressed air to clean the filter, this is going to happen. All the edges will get punctured. And when the edges are punctured, unfiltered air will escape from here, go to the next filter, and choke them. Now, it is the vacuum when kept in the fan section. It is when the fan discharge. Here, high momentum, the particle get small holes like this. So same thing applicable when cleaning compressed air. So either way, in vacuum it is diamond like this. In positive pressure, this small holes like this in the filter. Now, in rainwater, if it is the mud sludge, it chokes the filter like this, thick paste. What will happen? So there will be no air. You cannot expect the mud paste to have even distribution. They will unevenly. Somewhere it will be more, somewhere it will be less. This will be actual picture. Now, when you're using filters with box type, cassette type filters, the sliding gaps will allow the higher particles to pass through easily. So these are the various things. So now imagine when you are keeping this AHU and ventilation unit in the open to atmosphere, how much dust it will get. This is the next coming count. Now filter classification. Okay. After this COVID-19, many people are asking for this EU7 also. So this is the optimum grade where we can use. Okay. And IO 145 EU7. So dust spot efficiency is 80 to 90%. Okay, at PM1. So many people are asking this nowadays after COVID. Okay. Now, if you want to have these filters in very good condition, the pre-filters also should be in very good condition. Yeah. It's important to give better indoor quality. However, do we give good filter life is a genuine question. For effective IAQ, proper selection of sequence of filters is very essential. We have this sequence of filters G3, that is MERV 5, 6, and G4, MERV 7, 8, F5 and F6, then F7, recently introduced. This gradual reduction does not overload the F7 filters. Now, as I showed you here, you are putting 5 micron, then F7 filter. This is the combination as per after COVID norm. This has been revised here. So after 5 micron, this MERV 7 will also be come into place. So when you're having this gradual reduction of filters, naturally your indoor air quality will be better and the filter layers will also be better. Okay. When the filters are so due to fan pressure, the filter get damaged. This is unwanted unfiltered air passing through the final filter, later resulting poor air for the premise. This actually happens. Now filter gauge for pressure drop when fan selection. Pre-filter 90% efficiency 10 microns, 4 water column, then fine filter F5, this is the 7 then fine filter F7, 12 then 1 micron F9, 15 then 0.3 micron extent. So when you're calculating fan static, we should know what is the pressure of all these filters. Only then we can have a proper fan selection. Now, this is in the assuming that 70% filter is choked. Suppose what nowadays we are doing is we are like getting choked 100%, and we say there is no air, no air. Actually, it is not correct. You should have, if you see at this stage itself, you should start cleaning the filters. And I see here some punctures is there, some damage is there, some choking is there. So we should not wait for the entire filter to get choked and then start paying attention. So if you want to have a very good air quality, you should change the filters on time. Now here is the main topic. If you're putting the AHUs in a closed room and you're putting them open, We discussed some time back average. I'll just show you one second for refreshment. This PM 10 micron average range from 100 to 50 micrograms per cubic meter. So this data we are interpreting, and we are working on the life of filters. So 100 to 150 micrograms per cubic meter is the 10 micron particle load roughly. Now considering that 10 micron load, see now, if you're putting the room in a closed room, 80% choke, 0.36, airflow, this much CM, pressure drops, okay, approximate quantity. Time required for choking is 690 hours, okay, it's 20 micron. Then G4 is 500 hours, okay. Then F5 5 micron is 21 days, 520 hours. Carefully go through this. See, 20 micron will trap above 20, okay. 20 and below up to 10 will trap here, okay. And 10 to 5 will trap here. And again, we are sourcing of 2.5, that is PM 2.5. That means we had to go to F7 filters. So what will be the, again, further dust concentration will come down. We'll have a higher life expectancy. So when you put in the AHU in a closed room, this is the average time required for the filters to choke around 70 to 80%. Again, this also depends on how many times the doors are kept open in the AHU room, or nearby construction room is there, or some factory being built, or demolition work going on, something like that. Assuming the working factory, a working hospital, something like that, where you don't have any construction area going around, this will be the rough life of the filter to choke 80%. Now, if you go open atmosphere, see G20 in just 4 days for choking. Just see here, it is this much metric vapor will drag out of flow. Okay, this much okay, airflow required. Just see this much air here, 23,000, this much it has to flow. Okay, that's 4 days, then 5 days, then 5 days. This is a proven data we have taken from sites. Okay, we had a site where one AHU was kept in the open to sky, and one was kept in the closed room. The maintenance guy was telling, last week only we cleaned the filter, last week only we were crying again and again. Then we took this, worked out some of the data with the client and explained the concept, and they could recognize, yeah, these are the issues. So, and why the filters are getting damaged very often, then they could understand. After our suggestion, the client was happy, and they built a room for that AHU, which was kept in the terrace. So this makes a lot of difference. So these data, we are not just like that saying for the sake of saying. This is genuine, common sense. If you have something open to atmosphere, birds will come, leaves will come, mosquitoes will come, everything will come. You cannot stop them. But what will happen? They will choke the filters very fast. So when you're keeping the open to atmosphere in 4 days, filter chokes. Every week the people cry. Filter, and after much use compressor cleaning is more dangerous. It'll rupture the filter within minutes. So air quality will be disturbed totally. So my sincere request to all the participants is either to be designed for a comfort room or a hospital or any application. Please do not agree for putting the AHOs on the open to sky. Give a proper room. Only then the filters will be effectively maintained, and you change filters after a long time, not every week. And filter is a cost to you. Every week you are changing the filters, means how many filters keep on changing. The maintenance guy will ask for filters, and management will say you are spending too much on filters. There is no budget filters. That's the reply he'll get. So that usually happens because he has to buy 40, 50 filters a year. And the management will say every year buying so much filters. Next year capex you should bring down operation cost. You have to come down. All these things will come into discussions. So if you want to avoid all those things, one time you have to build a small room for the AHU, neatly keep it, and that's it. maintenance is very easy, filter life is better, and you have got a better life cycle of the AHU also. Not only that, open to sky will also another defect is you can have frequent rusting of the internal AHU base frame and all, because open to sky all rainwater everything will come, it will start rusting in the filter body, in the AHU body everywhere. So all those things also can be avoided. So this is the first point I would like to share is that keeping the AHUs in the open and outside, what is the difference? Okay, then we'll go to the next question. Consider the units working 24 hours. Average time required for cleaning shall be roughly every week. However, this for normal dry air only. In any days, the filter rainwater will form a thick sludge on surface and does not allow the air to pass effectively. So this is 4 days for raw dry days. In rainy season, there will be more and more mud sludge forming on the filter and informal. Now, expected life of filters. Frequent filter choking. This is partly choked. These are partly choked filters. That shaded one. Okay. Practically, cleaning of filters is the least preferred activity in the condition area. When the filters are choked, we don't get desired ACH, resulting in additional heat load on the chiller. Any chiller, including DX, loading, unloading is driven by a set temperature. When filter is choked, there is shortfall in degree by cm in the conditioned space. To compensate the temperature set point, the chiller loading, unloading time, running time reduces. So when the filters are choked, you don't get proper ACH in the room. What will happen is the dehumidified CFM does not match the required DCH load. So chiller will keep on running for longer load for longer time. Similarly for ventilation unit also. Okay, here also we're keeping the ventilation unit open. In many factories, the air washer, everything is kept open to sky. There's no room at all. They want to save a few rupees on construction of the room, but they keep on spending the money on filter. So these are the various things we would like to suggest. Now, types of AHUs, conventional unit draw through type. So we have here fresh air, mixing air, return air, then cooling coil, fan, heater if required, 10 micron, 5 micron. This is the conventional unit draw through type. Okay. Then we have there here no return air plenum here is there from the room directly pulling. So these two are normally many people using. Okay, one is like this, one no return air plenum. Directly the AHU room acts as a return air plenum. From the false ceiling air is coming, from the door pressure is coming, it is mixing the AHU room and it is going like this. Now this is a blow through unit which we discuss nowadays very often. Here have return air, fresh air, the fan is here, cooling coil. If you see here, cooling coil is here, fan is here. Here also, cooling coil is here, fan is here. Now, this first case, many of us are aware. There's a very, let us understand one thing. What happens is in this 1 and 2, there is a common problem in both the things. There's plenty of water condensation happening, and this water condensation goes into the room. So whenever you open the AHU door, you'll find a lot of water falling down because too much of water accumulation. Why it happens so? See, this fan is having a constant vacuum pull. Okay, this fan is having a constant vacuum pull. So to overcome this water condensate falling down, there should be adequate static generated by the water itself head so that the water drains off easily. In practical, this is what happens is the U-trap at the AHU outlet is not given proper consideration, not properly sized. Plus, there is no adequate slope for the U-trap to go out of the room. So what happens is the water accumulation is always high here. This will pull all the water down the line to the conditioned area. Suppose you do RH control system like that, then you'll find a lot of water carry, but RH will never be maintained. So in draw-through system, this is the biggest disadvantage. Okay, one more thing is in this kind, if you in one more thing, this second case, where there is no internal freedom, directly from the AHU false ceiling air is coming here, from the door is coming here, all getting mixed in the room and being pulled. Here also same issue, plenty of water stagnation inside the AHU body. In this case, one more thing is there'll be a heavy vacuum pull. You can't even open the AHU room door. Somebody wants to go to AHU room, he has to put a lot of efforts to open the door, go into the room, and check for the what is the problem. So this is a very conventional thing. You may spend little extra rupees by putting mixing a plenum, but what we are doing is we are putting acoustic enclosure to make it noise free. Here acoustic enclosure is not required because this is still acoustic enclosure. There's no noise. Here acoustic enclosure is required to overcome the fan pulling noise. And second thing is here the entire room is always wet because of the constant humidity coming from the outside. There is no condensation uh, happening here. So a lot of issues will be there. So in this case, when your AHU room is working as alternator freedom, pressure also mixing there, humidity is also adding there, cold air coming from the false ceiling. Everything adds to too much condensation and become always wet and slippery. This condensation humidity load again go on the coil only because there's already moisture from coming from the room and from the pressure, entire thing is coming here. So all this thing leads to a problem of high humidity. So this is one more big issue. And heavy noise because of the fan vacuum effect. So we are putting acoustic insulation. For example, this acoustic insulation that person may spend around 1 lakh rupees or so. But for the age return and premium, only 10,000 rupees you have to spend. A small age body. So 10,000 rupees for saving, you are spending 1 lakh rupees for acoustic enclosure. Why? I don't understand. So to avoid all these concerns, the best way is go for a blow-through system. In this blow-through system, what are the advantages? This fan is always having a positive push on the cooling coil. The U-trap will ensure always no carry forward water. Even there is a space constraint or no slope in the technical area, the U-trap can be taken out of the building and put outside the building because the fan positive thrust is always there to push the water out. So you can always see the AHU chambers dry. And we have written our fresh mixing film. So there's no vacuum in the AHU room, so no water condensation in the AHU room, and no acoustic extra required for the AHU room. These are the various things important while selecting the AHU design. So again, coming back to the same thing, in a draw-through mode, as I told you, master carry forward is very high. Many times water condensation is there. And whereas in blow-through, there is no water condensation. There are other effects also. I will just explain in the coming papers. Comparison blow-through and draw-through. Water carry very high since coil is in vacuum, negligible since positive pressure. U-trap shall be sized to overcome vacuum static. If not sized properly, heavy water collection in drain tray and water carry forward to supplier. Very small U-trap is required to just maintain a water seal. Maybe a 20 mm or 30 mm small U-trap is or U height is okay to maintain water seal. That's it. Drain pipe slopes. This many times we have seen in the installations where the technical floor where AHU circuit around 30, 20, 35 feet, the AHU drain water has to be taken out. So for the 30, 40 feet long, you don't have proper slope for the U-trap. What will happen? All the water will remain there for a long time. Whereas in this blow-through unit, if you don't have proper space, no problem. You take the pipe directly out of the building and give a U-trap there. That's enough. So constant push by the fan will ensure it will throw the water to the last point. This in some installations we have this practically done. The customer is going for renovation of the facility. For renovation of the facility, he wanted to increase the AHU capacity. So we told them going for instead of older type draw through, go for blow through. Initially, they were showing some resistance. Then they agreed. Then the place renovated to new AHU capacity. We put in place the new site of AHU, and after commissioning, they compared the performance, the older versus newer ones, and they found that yes, this blow through is much advantageous compared to draw through. There was no water accumulation. There was no issues of water carry forward like that. And after that, they there's a spirit capex. They removed all the old things with a draw through and converted to blow through. AG capacity was quite high, around 30,000 CFM or so. Initially, the 20,000 CFM, they completed two AHUs and become 30,000. So it was quite big unit. Like that, for fin they changed. It was for clean room application pharma. So it also we experienced those things. So after that, the client was very happy, and the client has now made it very clear in his SOP. All AHUs shall be go through only. So these are the things we have experienced. Now, if you keep the AHU outdoor, that wet are sucking by the unit. In rainy days, too much water condensation in the drain and water carries forward due to vacuum pull by fan. It's very high here. No issue. This also we had experienced same factory. All the HUs were kept some were in the open to sky, some were in a closed room. So we make them feel the difference. So we keep in the closed room and open to sky. They agreed for that, and again they made a small room to make them all indoors. So these are the things. And the most important part is belt slippage. Many people do not know what happens. The water droplets coming from the will come in contact with the V belt. It will reduce the friction and there's a power loss. Here there is no water carry forward. Again, go to the picture. You guys have comparison here. See, here you're having fan followed by cooling coil. So when coming to return, there is no water droplets here. Okay, so they always dry. Okay, whereas in here, what happens is water droplets coming in fan to the belt, so it will cause slippage. So this slippage around 3 to 8% is the expected power loss. Okay. Now, if you keep it open, it is more. Even in closed rooms, the slippage happens. Okay. If you're keeping open to sky, then you have rainwater coming in. The slippages are more. So either way, this is a huge loss. Energy silent killer of energy, which we don't know. Okay. That's why we always see that belt slippage is very important. A mist eliminator, many times ignored by designer. I just told you a few minutes back. This is a mist eliminator sitting over here. Whatever the flying particles, the water droplets will hit here and fall down. So we have better control of moisture carry forward here. Okay, along with water droplets and flying dust, then here the filter choking is lesser, whereas here with flying droplets and the moisture, filter choking is more here. Will become a very big paste, mud paste. RS control in this in blow through, draw through. RS control is very poor because of high water carry forward. Here is much better. Fungus mold here is very high because the most of times you find the drain tray with a lot of water accumulation. It will increase for mold growth. Nudging level since there is no water accumulation. Filter life. Filter choking by mixing of water and dust, which I explained you a couple of minutes back. Here again, the water droplets in here will come here, flying water droplets and moist dust will come here. They'll form a paste here. Okay. Whereas in this case, the water droplets are brought down here itself, and this minimal. So these are the comparison between the two. Now Return a connection. AHU room opening is considered return a connection. Separate plan is given to connect duct. So people should emphasize for return film in the AHU duct and don't compromise on it. AHU room noise. Quiet noise since constant vacuum pull by fan. In large capacity noise is much more. No noise, silent operation. Okay, with and without return film. AHU room acoustic. Additional expense of acoustic insulation. No need for acoustic insulation. AHU room door very difficult to open due to 5 vacuum fan. Is it open? So these are the some of the comparisons which we should like to share when you are deciding the AHU and the thing. Now again with or without runner plenum. Dust from nearby room. Since the AHU room is returner plenum itself high vacuum pull. Dust from all nearby place enter into the room, adding filtration load. So when the door is open, your dust and footwear, other things will come, so it will all increase the load. Here it is not that like that because film is there. AHU room condition very wet, especially rainy days. Cold return air promotes high water condensation in the room, always dry. Fungus and mold, high growth due to reason above. No condensation, no growth. AHU costs less since length is short, but additional expenses for acoustic insulation. More since length is big, but no additional cost for acoustic insulation. Now, here is the very, very important point. What shall be the AHU? Many people do not know the geometry of this. People say blow through length will go high, draw through length will be less, all this. What happens is, you carefully observe this picture. Okay, central have the fan motor assembly. For 10,000 CFM also, the person gives around 500 mm gap. For 40,000 also, the person gives 500 mm gap, half meter gap. Seeing half meter is okay to clean the cooling coil or whatever it is. It is not correct. Uh, actually, it be 30 angle both sides. Why I tell you? See, when you're having distance is less, what will happen is the angle of conversion is very, very less. So there will be heavy backlash here. I just draw one diagram and explain you. Just a minute. I just draw one diagram and explain you. See visible screen?
Not now, sir. When it was visible, please share it again. Yeah,
We see now.
yeah, it's coming now.
Okay, okay. See, this is the fan. Okay. Now I am putting here from here. Say, so this is the this fan. Left side is the fan inlet. Right side is the fan outlet. Okay. Now, say for 40 uh, 10,000 CFM, I put one clean this one like this. Okay, this is the distance of the filter or whatever is coming in first. Okay, now this is for say 10,000 CFM. Then I put for 40,000 CFM. So see the angle. For both, I'm keeping the same thing. Okay, this is the angle. Now, if you bring it like this, just see how the backlash is very. You are able to visualize the backlash now, correct? Now there will be a gradual transition. Okay, here you will see the there's a heavy backlash because the angle is very broad. Here is a gradual transition, both inlet and outlet side. So this is how actually behaves. So there is a separate formula. We have to evaluate the what is the fan mouth outlet, and accordingly we can work out the distance. What will be the rough free angle required for this smooth transition? What happens is many people don't consider this. They for all the same units they put the same gap. This is actually dangerous. There will be heavy backlash happening here because air will come and hit here and bounce back, hit here and bounce back. And your filtration will be affected this much portion only, filtration. The filtration will be only up to this much only, filtration will be affected here. Other area there will be no filtration. So this is the, see the filtration area, how much you're getting here. You're having a better filtration coverage here. So we are losing the filter also. One more thing is if you do a laboratory study of the filters in both the cases, the filter damage in center part here will be less. Here center part damage will be more because they are really coming into the fan attack. Here is having backlash, there is a poor airflow in this direction and filter damage in this area is poor. I would say healthy here. In this filter healthy here, whereas here it is heavy damage. Okay. And gradual transition means what will happen is there will be higher coverage of filter in the system. This is actually the things work out. So there's a formula for this. The same way either side, inlet, outlet, both ways. People say that for blow through, draw through, the length will go high. It's all not like that. Actually, it has to be done this way. These were the earlier practiced systems. Later on, they were diluted because of various changes in various top requirements, like space is not there or building size is not there, save on cost, and slowly they has been gradually nullified. So this is a very, very serious effect people do not know. Okay, this is what I want to basically emphasize on. Yes, clear now? Hello? 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 I'm audible? Hello? 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 I think something gone with audio. Hello? 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 I think something audio lost, I think. Sorry. Hello? Hello?
Hello.
Yeah, I'm audible now?
Yes, sir.
Yeah, there was some disturbance between. Yeah, okay.
Okay. So
Yeah, now,
actually, your that is on. Can you go through the slide so it will be better visibility then?
yeah, yeah. Visible now?
Yes, sir.
Yeah, the sketch we were able to see a few minutes back. I draw some small sketch. You able to see the sketch? Yeah. Hello.
Yes, yes, sir.
A few minutes
Come
back,
again.
a few minutes back, I draw and sketch. You saw that?
Yeah, all
Okay,
things are visible. Yes.
okay, okay. That in a small round, and I made a small sketch. I made. Okay, fine. Okay, good. So some general assumptions in cone angle. Okay, inlet 3D, outlet 5D. Cone angle is not overcome backlash. Both sides shall have approximately 30 angle as indicated in the sketch. Okay, 400 to 500 space is provided on both sides of the fan. Cone angle is not adequate to overcome the backlash. In large capacity, the backlash is very high since the cone length is very small for smooth transition. Now, these are the summary. Now, AHU installation shall be kept indoors. Placing the units open to atmosphere choke the filters very fast, increase filter replacement cost, and reduce the cooling efficiency and ventilation efficiency. Blow through versus draw through. Blow through units have lesser moisture carry forward, hence better control over it since no moisture carry, no built slippages. So then another thing is with return air mixing air film, AHU room, no noise, no and acoustic ventilation not required. AHU room not in vacuum, no additional dust entry into the AHU room, and increased filter life. AHU room no much accumulation, hence no fungus growth. The fan inlet outlet cone length, adequate degree of angle should be given on both sides to have gradual transition airflow, reduce fan backlash, and reduce power consumption. So these are the various things I would like to summarize here. Now let us have the feedback and questions from the people. Hello.
Yes, sir.
Yeah. Question answer, please.
Okay. Is there any more slides are pending or
Yeah,
anything?
that's it, sir. That's it. Yeah.
Okay. So, uh, first question that is happening, what we have received from Raj. Sir, I have a question about heat load calculation. In heat load calculation, we are using E20 seat. In that seat room, sensible and latent will be dissipate. Why are using sensible load only on the dehumidified CFM?
See, heat load is a combination of sensible and latent heat. Somebody say sensible latent heat is not right. It's a combination of heat load. Okay, when you have to have a better RH control, then latent heat plus sensible both plays both factors. And a given coil load section also depends on the total heat load. So please consider total heat load, not specifically latent and sensible. It will be a combination of both. Okay, next step.
Filter washing frequencies is asking for filter washing
See,
frequencies.
I just I was passing through the various questions. If you're keeping the open to atmosphere, hardly 1 week the filter life, been choking time. If it is kept indoors, it's almost 3 weeks. So there are methods to check the filter healthiness. Testing kits available. Or you just put the filter in the testing kit and give air. You'll know what is the life of the filter. And do not use compressed air to clean the filter because it will damage the filter very fast. People what they do is they use compressed air to clean the filter and it will damage all the corners and things. If a media filter, just use and throw. Media filter, do not wash them up. Just use and throw. If it is a fabric filter, you can wash them. 3 or 4 wash. That's all. Next, sir. Hello. Hello.
Yes, sir.
Any questions?
Need to know how internal static of HQ is calculated, sir.
See, Static is already we have to do the ducting pressure loss. Everything is there. Okay. Last time in my ducting training program, I given the calculation how ducting is calculated. Friction loss across ducting, friction loss across filters, everything is to be calculated to select the static of the fan. What happens is somebody assumes system static, but actually the system does not require system static. Then only thing is your fan consumption power will be high. So we have to the separate formula to work out the ducting friction loss. You have to work out that and then only you can convert. Any more questions, sir? Hello?
Yes, sir. Someone is asking about the number of washing cycle.
See, number of washing, that's what I told you now. If you're keeping the AH in the open, every week you have to clean the filters. And if it is hit washable filter, like a fiber type, you can clean them, wash them. If it is not a the media filter only use and throw. You cannot wash media filters. Media filters only use and throw. Nowadays, people are going for media filters.
How to calculate internal I think we have taken it.
Yeah, we have to complete the total ducting, pressure loss, and workout. And yeah.
Internal static pressure, I think we have already taken.
Yeah.
Or for hygiene unit, when there is HEPA filter after fan, then is it necessary to provide back filter just before HEPA so as to increase HEPA life more?
No, no, HEPA filters, you are not supposed to put in the AHU body, first of all. Okay. HEPA filters are designed for a velocity of 90 FPM. Okay. In AHU body, you got 500 FPM of air. What will happen is 500 FPM of air, the flying particles of less than 5 micron will go and hit the HEPA like a bullet and puncture them very fast. So never put AHO chamber HEPA filter. It will be only tunnel only with adequate depth sizing and velocity sizing. Otherwise, it will be damaged very fast.
Is G4 filter washable or any replaceable
G4
or
filter,
only reusable?
G4 filter is presently washable only. Okay, G4 filter only washable, but 5 micron now being gradually going by media filters. Washable also available, but slowly market is changing. They are now going for media only 5 micron.
Who is economical blow through or draw through type?
See, economical means a very AHU construction. What are the components in the AHU? That is first thing. So if you want to cut on size, as I told you, people do not put return or premium. You're cutting cost. Okay. Whereas if you put return or premium, there is no uh, requirement of aquatic insulation and there's no water condensation in the AHU room. And as I told you, blow through will not have any water carry forward in the system. The draw through is fan is in vacuum. It will pull a lot of water droplets and it will carry down the line to the system. So please consider blow through. That is fan on the discharge you have cooling coil. Then mist self These two components have a very important role. Otherwise, the master carry forward down then will be very high. I always recommend a blow through only. I don't recommend draw through.
Can we put diffuser after fan, then HEPA to reduce air velocity if there is no space at terminal or HEPA?
Hey, why do you require diffuser? I don't understand. HEPA, you're putting HEPA, it is a filter. Putting a diffuser doesn't have any purpose before the HEPA. Duct sizing has to be done properly with with some damper like that.
Some question is there. Best way to conclude the HU size considering 500 FPM Q is equal to A into V. Using the formula filter size can be confirmed. How much excess to be considered for HU size?
See, 500 fpm is the average velocity of filter. Okay, 500 can be brought down to 250, 300 also. AHU size will go a little bigger. But one thing is that lower the velocity, higher the filtration level you get. But again, the fan cone angle, what we explained little minutes back, the fan cone angle, the 30 degree angle. If you don't have proper cone angle from the AHU inlet and fan inlet and outlet, whatever you put, the filter will be losing life fast. Many people do not know the importance of putting the cone angle for a fan inlet and outlet.
If you are using VRV, VRF ODU, in which side DX kit is pre-fitted, and what are the all factors to be considered?
See, VRV or a chill water, both are energy source only. Okay, it's only a energy source to give cooling energy to the AHU. We are talking of only the main thing is how to what is the difference between putting the AHU inside the building or outside the building. Number one. Number two is blow through and draw through. We are comparing the advantages and similarities of these two things. Okay, so if you go for VRE based system also, I would still recommend that you put the AHU inside the closed room with proper internal plenum and make it a blow through type, not draw through type.
We are having HU whenever water circulation stops on pads. We observe fishery smell. What's the reason?
Yeah, water getting see any water after circulation will pull all the atmosphere dust. It will give growth to microbes. We have to replace the water and add some treating chemicals to as a disinfectant to kill the germs. That's it. In air washer, it's very common, especially in summer to monsoon changeover time. Very common in air washers.
Please advise for external vibration isolator type, isolation efficiency for floor mounted HU installation.
See, vibration isolator is usually kept inside the AHU body, inside the AHU body, where you have fan and motor sitting on a common base frame. Okay. Now, as long as these two are in a puff or a rockwool based panel, vibration doesn't transmit to the ground because puff or rockwool they are also to some extent vibration isolation pads only. The only thing is you should know the rigidity, how effectively is fixed onto the base frame. If it's not fixed rigidly, then the high vibration it will to topple of the motor from the base. That's all. Otherwise, it's very common thing. There are few renowned companies which give this.
How to clean MURV?
See, more filters, as I told you, nowadays people are going for media filters and not fabric filters. Okay, that is F5, 5 micron, 5 micron, and down the line are not fabric filters. They are media filters only. Before that, 20 micron, 10 micron, we are having both media and synthetic fiber filters. If you are going for a media filters, you cannot wash them. You have to use and throw. Whichever filter you are, sorry, media filter or sorry, 10 micron, 10 micron, whatever filters are sharing, only thing is washed with a mild soap solution and with small like hair blower like that, small blower to remove the dust. That's all. Don't use composter. If you composter, then it will get damaged. You will not have any. You not have any control over the pressure from the composter.
How to clean micro
How to clean?
micro?
Micro V again. Micro V is again. See, any filter first you dip them in a soap solution for 30 minutes or so. Then I'm not talking about fabric this media filter not washable. If you put come in water, they'll damage fast. Washable filter you soak in soap solution for 30 minutes or so and make them dry with some small hand blower. Okay, not compressed air. It does enough to get away the dust.
I think all the question has been well taken, sir. I think around 30 question has been asked. So it shows that how interactive this audience were. So anything else pending from your side you can add, or we can go for the last session, last agenda point of this session. That is what vote of thanks.
See, my only thing is I would tell all the people to switch on, putting the AHU in open atmosphere. Don't prefer that. Please put them in a closed rooms so that you have better filter life and better performance. Otherwise, it will be very, very difficult to manage, because in every company, every year they want to cut down the budget for maintenance, and filter is one of the biggest expenses in any company. So you switch over them, make them to put in a closed indoors so that you will having a better life cycle of the equipment. I am giving my email ID and mobile number in the chat. You note down.
So you have sent it on, yeah. That is mkservice69@gmail.com. Mobile number that is 99401766973. So you can note down the number of Mullikan sir for any further queries and all. And one more request from all of you, one who is non-member of Delhi chapter of ISHRAE, I have sent across the link to join the Delhi ISHRAE. It is very easy. When you click the link, you will find all the options. Very nominal amount is there for the 3 years. This is the only way you can support us. Other ways are also there, but this is the best way to support us. Whenever members joins us, we feel like motivated and boosted all kind of things to do what we are doing. Your supports are already welcome. Your ideas are already welcome. You can send your ideas regarding the workshop at info@dcsray.org. If it is feasible, we'll definitely apply those ideas after approval of the committee members, program chair, and other teams as well, who is looking after the programs and all. So once again, we request you to join Delhi chapter of ISHRAE through this link. And uh, there are lots of program apart from the online program. We have a physical program like cricket we are organizing, Bandcom we are organizing. I mean, Equicomp is there. So Pharma Fest is going to be there. So many physical programs are there, and members we have AGM also there. So there are lots of opportunity to get network in your area, HVAC and refrigeration industry. So this is the, I mean, a non-compatible platform, I would like to say, and this is the platform we disseminate knowledge for the members through online, through physical programs. Many standards we have, technical committees we have, many things you can explore in terms of knowledge, in terms of network, in terms of business opportunity. So this is the best way we can explore. I mean, in all dimensions, X, Y, and Z axis. I would like to say. So final agenda for the day. I request Youth Chair Mr. Akash Saxena to make vote of thanks for this session. Thank you. Over to you, Mr. Saxena.
Hi, thank you, Tapas sir. Am I audible?
Yeah.
Perfect. Yeah.
Yeah. First of all, I would like to thank Mullikan sir for taking out his valuable time for Delhi chapter of ISHRAE and delivering this workshop. It was really a great workshop, sir. I hope everybody must have learned a lot from your experiences, and everything you taught was really amazing. So I hope, yes, everybody would cherish their day attending this workshop. It was really a great session, sir. Thank you so much. And before signing off, I would like to thank our platinum partners Amacel, gold partner ALP Aeroflex, KSB, silver partner Briar DRI System, Advanced Wall, Mervex, and Bits, annual partner Paramount Polytreat, KFlex, and membership partner Standard Refrigeration. Thank you so much, everybody, for attending this session, and thank you so much, Mullikan sir. It was a pleasure hosting you, sir.
Oh, thank you very much. Yeah.
With permission to all, then should I close for the session?
Yeah, please.
For the day.
Okay.
So I think we will make another session on this topic. We'll talk further with you, sir.
Okay.
Okay. Thank you very much, sir. Thank you, everybody. Thank you, all of you. Thank you, Kasak Sen. Thank you very much.